For Unit 1, Goal 14, there are 4 problems on the pretest, starting at number 51. If we look there, we can see this is really going to be kind of an algebra exercise. What we're trying to do is interpolate and extrapolate using an equation. So if y equals 0.5x plus 3, which is the equation that's given, they want to know what the value of y is if x is 8. So if I plug in for x, 8, and solve, 0.5 times 8 is 4 plus 3, y turns out to be 7. So the right answer is A. 52. If y equals 0.5x plus 3, same equation, y equals 0.5x plus 3, what would the value of x be if y is 8? So now, pay attention, y is 8. So I have to substitute 8 in for y, and I'm going to solve now for x. So the way I do that is I'm going to subtract 3 from both sides. You got to do a certain order of operations. 3 minus 3 is 0, so that drops out. 8 minus 3 is 5, so 5 equals 0.5x. So now I have to divide by 0.5 to get x by itself. So x equals 5 divided by 0.5 is 10. So the right answer is B. The last 2 problems are 55 and 56. So if an equation turned out to be v equals 5t plus 4, and I want to solve for v if t equals 4. So I'm going to replace the t with 4, and I'm going to solve. 5 times 4 is 20. You have to do the multiplication first, then add the 4. I get 24. So the right answer is B. For the next one, v equals 5t plus 4. I'm going to solve for t now if v is 14. So I'm going to plug 14 in for v, 5t plus 4. So now I have to subtract 4 from both sides. This drops out over here. 14 minus 4 is 10. 10 equals 5t. So now I need to divide both sides by 5 to solve for t. So t ends up equaling 2. So the correct answer is A. On your practice worksheet, the Your Turn, we actually have a little more work to do because we have to first write the equation and then use it. So if I'm going to do this really quickly, I'm going to have to extend my line to get the y-intercept. So go ahead and do that. And then I'm going to figure out where it runs into the axis. It looks like this is 10, 12, maybe I think we used 13 before as where it runs into the y-axis. So I'm going to write the equation. Remember, y equals mx plus b. So my y value is going to be, I'm just going to leave it as y because they're giving us x and y's. So my slope would be, let's see, if we use this point, and I'm not sure what another good line, this is not a great line, so we're going to have to do a little estimating. It's okay if we're not perfect here. I do like how it runs in down here, so I think I'm going to make my line go all the way down. So I'm going to say this is 80, right? So I'm going to say my rise would be 2, 4, 6, 8, 10, 12. My run would be 10, 20, 30, 40, 50, 60, 70. So my slope is rise over run, which is 12 divided by 70. So that would be, quick calculation, 12 divided by 70 equals 0.17. So I'm going to plug that in for my slope. 0.17x plus my b, which we decided was 13. So all I have to do now is use it. So they say, what would y be if x is 8? So I'm going to plug 8 in here, multiply it by 0.17, and then add 13. So 0.17 times 8 equals 1.36 plus 13 ends up being 14.36. We'll round it to 14.4. Now, calculate what the value of x would be if y equals 8. So I'm going to write my equation down again, 0.17x plus 13. So now they're giving me y is 8. So I'm going to plug 8 in here, 0.17x, and solve for x. So what I need to do is subtract 13 from both sides. So what is 8 minus 13? 8 minus 13 equals negative 5 equals 0.17x. So to solve for x, I have to divide by 0.17 on both sides. So negative 5 divided by 0.17 equals negative 29.4 would be what x equals. One more problem on the next page. 27, same idea, draw a line of best fit. So I'm going to do that. So my equation is going to be y equals mx plus b. So I have to find the slope. So if I do that real quick, I think my slope can be here at 30. And let's see, down to 15. So if I make a triangle here, it rises by 5s. So 5, 10, 15. The bottom goes by 1. So 1, 2, 3, 4, 5, 6, 7. So my slope is 15. My rise divided by my run, which is 15 divided by 7, which equals 2.14. So we'll say 2.1. Where does it hit? It hits at about 6. So that's going to be my y-intercept. So y is going to be velocity. M is my slope of 2.1. X is my time. Plus b is where it runs. The line runs into the y-axis, so it's 6. So now they want me to use the equation to determine what the velocity would be at 14 seconds. So 2.1 times 14 plus 6 is the math I'm going to have to do. So 2.1 times 14 plus 6. So it turns out to be 35.4. So we're hoping that's close, right? At 14 seconds, we can do a quick check. Sure enough, it's pretty close to 35. Now, use the equation to determine what the time would be. So we're going to use the same equation, but instead, we're going to be given a velocity. So velocity is 11 equals 2.1 t plus 6. So you subtract 6 from both sides. That 6 minus 6 is 0. So 11 minus 6 is 5 equals 2.1 t. So I divide both sides by 2.1. It cancels out over here. So t equals 5 divided by 2.1, which turns out to be 2.3 or 2.4 if I round it. So the time is there.